All right, so on Friday we talked about the OR probability. That means you're adding the two separate probabilities. For NOT, you're doing 1 minus, and for AND, the rule is going to be to multiply the two probabilities. So for example, this works for independent events. What that means is if two events are independent, if the occurrence of either of them has no effect on the probability of the other. So if I take a coin and I toss it and I get heads, if I toss it again, does me getting heads on the first attempt have an impact on my second toss? No, you could keep getting heads and heads and heads, or tails, or a mix of the two. So that would be, it's an independent event. Let's say I wanted to find the probability of picking a red pen out of my little pen box. So how many do I have? I have 3 of them, right? But if I take one out, what happens with the probability? It changes, right? Because I took one out, so there's less chance. If I take this out, there's less chance. If I take this one out, now there's 0 probability. So this would not be independent because it depends on me taking out the red pens from my little box. When you're tossing a coin, you know, when a fair coin is tossed 2 times in succession, so one time after the other, the set of equally likely outcomes is, can you get 2 heads, right? One and then another one in a row. Can you get heads and then tails? Can you get tails and then heads? Can you get 2 tails? So any of these 4 outcomes has the same probability. We can use this set to find the probability of getting heads on the first toss and heads on the second toss. So that's this situation right here. It's the HH. What's the probability of that? Well, there's 1 out of the 4 possible outcomes. Now, listing the possibilities for this problem, there's only 4 of them. But what if you were tossing it for 100 times? That would be a lot of possibilities to list. So there is a formula that involves the multiplying that I just talked about. Okay? The probability of heads on the first toss is 1/2. The probability of heads on the second toss is also 1/2. So what you would do is multiply 1/2 times 1/2 to get 1/4, which is exactly what we found by counting out the different outcomes. So the formula for probabilities with independent events, if A and B are independent events, one does not affect the other, probability of A and B is found by multiplying. So why don't you guys read number 1 to yourself about roulette? Has anyone played roulette? Do you know what it looks like? It's like a spinning wheel. So how many black spots do we have? How many green? How many red? So when you're being asked about, excuse me, find the probability of red occurring on 2 consecutive plays, that's probability of red and red happening again. So because it's and, we're going to multiply. What's the probability of getting a red on the first spin? Well, there's 18 out of how many? 38. Times how many reds do we have again? Again, 18 out of 38. Why don't you guys multiply this and reduce right away? Use the alpha y or the math fraction because it's going to give you big numbers otherwise. And you always want the reduced fraction. Check that you get the same number as I did. Next one. Find the probability of green and black occurring on two consecutive. Consecutive means one right after the other. So what's the probability of green? 2 out of 38 times, there's 18 black out of 38. Multiply and reduce. Did you get 9 over 361? Okay, 2 more problems. If the probability that South Florida will be hit by a hurricane in a single year is 5 over 19, okay? So what's 5 over 19 as a percent? What does that really mean? Because 5 over 19, what is that percent-wise? Times 100, so it's 26%. That's pretty high. They're going to be hit by a hurricane, and that's a 26% chance of it happening. What is the probability that South Florida will be hit by a hurricane in 3 consecutive years? So it's probably of hurricane, and hurricane, and hurricane. So the and tells me to multiply 5 over 19 times 5 over 19 times 5 over 19. How else could we write this down? If you don't want to type this into your calculator with all these fractions, you could do 5 over 19 to the 3rd power. Does the same thing because the calculator is going to multiply it 3 times. And it's 125 over 6,859. And if this number doesn't maybe like help you understand this, let's actually divide. And it's 0.018, so it's 1.8%. So in 3 consecutive years, that's actually a very small probability of it happening, okay? What is the probability that South Florida will not be hit by a hurricane? So not means 1 minus. So probability of no hurricane, it's 1 minus the probability of it happening. So what am I subtracting? What's the probability of the hurricane happening? It's 5 over 19. So if you want to find the probability of something not happening, you do 1 minus 5 over 19. Which is 14 over 19. So now if it says, what's the probability of no hurricane for 10 years? What you would have to do is multiply 5 over, not 5, my bad. Scratch that. 14 over 19, because we're doing the no hurricane. 14 over 19, 14 over 19, so on and so forth. So maybe it's easier to just do 14 over 19 to the 10th power, because we're being asked about this being for 10 years. And when I did that, I got 0.0471. So that's like 4.7% chance of it not having a hurricane for 10 years. Okay? We're going to add one more example. Find the probability of rolling a 5 3 times in a row. And so basically this is a dice problem. How many numbers do we have on a dice? 6. How many 5s do we have on a dice? 1. So if we're doing probability of 5, that's only 1/6. On one toss of a dice, there's a 1/6 probability you're going to get a 5. But since we are rolling it 3 times, we're going to multiply 1/6 times 1/6 times 1/6, which is 1 over 216. Hi. Yep, he's here. So that finishes up 11/7. I feel like the end probability with multiplying is the easiest out of the 3, I think. So here's what we're going to do today. I would like you to find your practice packet. Today we have some time for you to actually get some work done in class. I would like to check pages 1 through 9 in a minute, so I'll look at that. But what you guys are doing right now is 12 through 15. 12 through 15, that's 11:6 and 11:7. You should be able to finish those in class today. So page 12, 13, 14, and 15 needs to be done in class today.